So here are some practice problems, like problems in the assignment for 5.5. I would suggest that you look at the problems that are posted on Foxtail in a PDF and work those problems out as much as you can before looking at this video, before looking at the answer key. So this first one is like number 4 from the assignment. We want to construct a polynomial of least degree using this given information. So we are given that we've got real roots of 4 and negative 1/4, and they both have multiplicity of 2. So let's start to construct this polynomial. So I think we're used to now knowing that we're going to have some multiplier out in front, which we call a, and then each of those real roots, which root is another word for 0, come from a factor. So 4 comes from the factor x minus 4, and it has a multiplicity of 2, so we're going to put an exponent of 2 on there. All right, now what about that negative 1/4? So if we were to write that just like we would if it was just an integer, we would write x plus 1/4. Okay, we want to actually not have a fraction there. So we want to think about how would we end up with x equal to negative 1/4 if we don't have a fraction? Well, if we multiply this factor x plus 1/4 times 4, distribute that out, we end up with 4x plus 1. Okay, now let's think about if we set that equal to 0 and solved, we would go 4x equals negative 1. Divide both sides by 4, we would get x equals negative 1/4. Okay, so we end up with the 0 that we want, and we only have integers, we don't have fractions. So that is the other factor that we're going to put in here, 4x plus 1. And then that also has multiplicity of 2, so that gets an exponent of 2. All right, so that gets us set up to start off with. We now have this other piece of information that we want to use, and that is that 1 f of 1 is equal to 1 negative 4. So what that's telling us is that when x is equal to 1, the function value f of 1 is equal to a negative 4. So in our function that we have set up, we're going to replace f of x with negative 4 and replace x with 1. So we end up with a times 1 minus 4 squared times 4 times 1, replacing that x with a 1, plus 1, that quantity squared. And now the only thing that we don't know is a, so we want to solve for a. So we have negative 4 equals a times, well, 1 minus 4 is negative 3. And then 4 plus 1 is 5. So we get negative 4 equals a times negative 3 squared is 9, 5 squared is 25. So we get negative 4 equals a times 9 times 25 is 225. Let's just go right here. So 225a equals negative 4. So to get a, we divide both sides by 225. And we get a is equal to negative 4 over 225. All right, so now we can write down our function f of x equals, plug in what we found for a, negative 4 over 225. Go back to using x minus 4 squared times 4x plus 1 squared. And that is our polynomial function of least degree. This practice problem is like numbers 5 through 8. We're going to use our rational zero theorem to find all real zeros. We're going to find that the possible rational zeros are factors of the constant term. So possible rational zeros are factors of the constant term. Factors of 45 are plus or minus 1 plus or minus 45, plus or minus 9 plus or minus 5, plus or minus 15, plus or minus 3. All right, so we're going to use synthetic division to test out these possible rational zeros to see which ones actually are zeros. So I hope that you have already practiced this and have figured out that 3 is a good one to try out. So let's go ahead and bring down the 1, multiply, add down, multiply, add down, and then multiply, and we add down and we will get a 0. So that gives us our confirmation that x equal to 3 is a 0 of this polynomial. All right, so we want to find other possible rational zeros. So let's first write down the factored form. We've got x minus 3 comes from that 0 of 3, and then we have another factor that comes from these coefficients that are to the left of the remainder. So we get 1x squared minus 2x minus 15. X squared minus 2x minus 15. So to get our other real zeros, we're going to take that quadratic factor, set it equal to 0, and solve for x. So we want to first see if we can factor this. And we have x and x, and we can find two values, negative 5 and 3, that multiply to negative 15 and add to a negative 2. So we get other real zeros of 5 and negative 3 to add to the one that we already found of x equal to 3. This practice problem is like 11, 12, and 14 from your assignment. We want to find all complex solutions. So that means that we are looking for real solutions and non-real solutions. So first thing to do is to write down all possible rational zeros, and that is going to be the factors of negative 40. So the factors of negative 40, we're going to have plus or minus 40, plus or minus 1, plus or minus 20, plus or minus 2, plus or minus 10, plus or minus 4, plus or minus 8, plus or minus 5. And now we want to test some out to see which ones are the actual possible rational zeros. Okay, hopefully you have practiced this and you have discovered that 4 is a good one to try. So let's write out the coefficients, 1, negative 10, 34, negative 40, and go through the synthetic division. Bring down the 1, multiply, add down, multiply, add down, multiply, add down, and we get a 0. So that means that 4 is a 0. It's a real 0. And then our next step is writing the function in this factored form. The factor that 4 gives us is x minus 4. And our other factor is going to be quadratic with these coefficients. So we have 1x squared minus 6x plus 10. So x squared minus 6x plus 10. We can try to see if we can factor that. But x squared minus 6x plus 10 is not going to give us two numbers that will multiply to 10 and add to a negative 6. So we're going to use our quadratic formula to find our other zeros. So we get x equals 6 plus or minus negative 6 squared, which is 36, minus 4 times 1 times 10, so we get minus 40, all over 2 times 1. So simplifying, 6 plus or minus, we're going to have a square root of a negative, so our other zeros are going to be complex. We have a negative under the square root, so 6 plus or minus, that's going to simplify. The square root of 4 is 2, square root of negative 1 we write as I, and then that's all over 2. We want to write that as the real part, which is 6 over 2 plus or minus the imaginary part, right, which is 2i over 2, and then we see that we can simplify to 3 plus or minus I. So the list of complex zeros are x equal to the real 0 that we found of 4, and then the two complex zeros, 3 plus I and 3 minus I. This practice problem is like number 16. Here we want to construct a polynomial that has least degree using the information that's given to us. So we know that our setup is going to be f of x equals, we have some unknown multiplier out in front, and then we're going to have factors that go along with those real roots, which again, roots, that is just another word for zeros. So for 4, we get x minus 4. Negative 4 gives us the factor x plus 4. 2 gives us the factor x minus 2, and negative 2 is the factor x plus 2. And we're not given any indication that multiplicity is other than 1, so we just leave it like that. Okay, the other piece of information that we're given here just means that when x is negative 3, the function is equal to negative 5. So we can replace f of x with negative 5 and x with negative 3. So everywhere we have an x, we're going to plug in a negative 3. All right, so we get negative 3 minus 4, negative 3 plus 4, negative 3 minus 2, negative 3 plus 2. Simplifying further, we get negative 5 equals a. Negative 3 minus 4 gives us a negative 7. Negative 3 plus 4 is a 1. Negative 3 minus 2 is a negative 5. Negative 3 plus 2 is a negative 1. So negative 5 equals a times, we want to multiply those things together. Negative 5 times negative 7 is a 35 times negative 1. We're going to actually end up with a negative 35a. Divide both sides by 35, negative 35. And we end up with a equaling negative 5 over negative 35, which simplifies to 1/7. So we go back to writing the function f of x equals, replace the a with 1/7, and then go back to using x's. X minus 4, x plus 4, x minus 2, x plus 2. And that is the polynomial in least degree with those zeros.